For part B of section 3.5, we're going to look at the idea of the oblique asymptote. Oblique, also called slant asymptotes. These only happen if the numerator's degree is one bigger. So we talked about if the numerator's degree was smaller or equal, that was a horizontal. If it's one greater than the denominators, then that's an oblique. And the way we actually figure out the oblique asymptote is we actually divide the numerator by the denominator. That'll give us a slanted line, a y equals mx plus b kind of line. And when we divide it, we will ignore any remainder that's on there. Now, this may lead to the question, what if the numerator is 2 bigger or 3 bigger? Those get more complicated, and we won't deal with those at all. On the first problems here, though, we're just going to visually figure out the asymptotes. So this one has vertical asymptotes. Notice my tick marks are every 2 on this. So I have a vertical asymptote at x equals -2 and at x equals +2. This one has a horizontal asymptote. And that one is down here, 4. So that's going to be at y equals -4. It also wants the domain. So from left to right, my domain, well, I go from -infinity until the first break in the domain is at the first vertical asymptote, -2. Then the graph exists between -2 and 2. Sorry, -2 and 2. And then the graph exists from 2 to infinity. Letter B, this is what a slant asymptote would look like, or an oblique asymptote on an angle. So this one has a vertical asymptote still, though. And let's just kind of eyeball this. Let's say that's maybe, let's call it a half. Might be 2/3 or something like that, but it's something between 0 and 1. Now, this one also has an oblique asymptote, and again, that's new. But I'm going to do the equation of a line, y equals mx plus b. Well, looking at this dashed line, it's hitting at 1 on the y-axis, so that's my y-intercept. And then it looks like it's also probably hitting right here. So that would be up 2 over 1. So that would be 2x plus 1. Now, as far as the domain, basically I look at from left to right, this thing would expand forever to the left. So -infinity, and it exists until I reach that vertical asymptote, just like on the last problem, 1/2. And then it picks back up right after 1/2 and goes infinitely far to the right because this piece of it would continue to shoot off to the right. So going back to some more complicated ones, looking at the equations and figuring out the asymptotes from the last section. Vertical asymptotes make the denominator 0, but not the numerator. So what would make the denominator 0 here would be -2. So x equals -2 is my vertical asymptote. Then I've got to ask myself, does this have a horizontal or oblique asymptote? That's based off of the degrees. The degree on the top is 1, degree on the bottom is 1. When they have the same degree, we take the leading coefficients, 1 and a 1. The ratio of those is my horizontal asymptote. So it's going to be y equals 1 over 1, which is 1. So you can either have a horizontal asymptote or an oblique. You cannot possibly have both because they follow different rules. On letter B, I'm going to figure out what makes the denominator 0. So if I factor this, I get two numbers that make the denominator 0. And if I test, neither one of those make the numerator 0. So this has two vertical asymptotes at x equals 7 and at x equals -5. Then I ask myself, okay, does this have a horizontal or oblique? I look at the highest powers, which they are equal again. So just like on the last one, I'm going to take the leading coefficients. In this case, it's going to be 3/1. So my horizontal asymptote is y equals 3/1, which is 3. For letter C, again, vertical asymptotes, what makes the denominator 0? Well, that would be -2 again. This one, though, this is a new case. The numerator's degree is 1 larger than the denominator. The numerator has degree 2, denominator has degree 1. So this is going to have an oblique asymptote. And now the way I find the oblique asymptote is I actually perform the division. We can use synthetic division to do this. This is going to be, since it's x plus 2, I'm synthetically dividing by -2. I'm dividing this, which is going to be 1, 0, because I need a placeholder, 6. So I'll drop this down, go through my synthetic division stuff. And on the top of the lesson, I said that we'll ignore the remainder. So this went from an x squared down to a x. So this is going to be x minus 2. Now remember, this is the equation of a line, so it's y equals x minus 2. So that would be the slanted line that is an asymptote of this. Notice that every time I've talked about the vertical asymptotes, I've said makes the denominator 0, but not the numerator. If there's a number that makes both the numerator and denominator 0, that's actually the x-coordinate of a hole in the graph. So now we're going to add this possibility of getting a hole in the graph. I would suggest factoring this first. So the numerator, I could bring out a 2. And then I could further factor that. So this would be 2, x minus 2, x plus 2. On the denominator, if I factor that, that'd be x plus 6, x minus 2. So let's go back to our asymptotes. Vertical asymptotes is what I usually look for first. What makes the denominator 0 but not the numerator? The only number that would make the denominator only 0 is -6. So there's a vertical asymptote at x equals -6. Horizontal or oblique asymptotes. Look at the degrees. Highest degree on top and bottom is the same. So I'll take the coefficients in front, the numbers in front. So that's 2/1. So I have a horizontal asymptote at y equals 2. But now this one has a hole because the number 2 there or 2 there, 2 makes the denominator and the numerator equals 0. So this means there is a hole at, now the hole is an x and a y point. This is where things get funky. So it's 2 comma something. Well, the question is, what is the y coordinate? here's the problem. Usually when I have an x, whenever I have an x, I just can plug it in to the machine for x's and get the y value. That's not going to work here though, because I know that's going to give me 0 over 0. That doesn't make sense. So here's what we have to do on these. We have to take our factored form, cancel out the factor on top and bottom that's causing it to be 0 over 0. That would leave me with 2x plus 2 over x plus 6. Now I can plug this value in, and it's not going to give me 0 over 0. So that would be 2 times 4 over 2 plus 6. So I end up with 8 over 8. The y coordinate is 1. So again, I had to factor and then reduce to figure out the y coordinate of the whole. For the last two, we're going to do some factoring and reducing to figure out where the whole is. So the numerator here is x plus 3x minus 3. Denominator is just x minus 3. Now there's no number that makes the denominator 0 that does not make the numerator 0. There's no number that satisfies that. So there's a hole in this graph. That hole is at, well, the number that makes the bottom and the top 0 would be 3. Just like we did on the previous problem, to figure out what the y coordinate of that is, I'd reduce this down to just x plus 3. Now if I pop 3 into there, 3 plus 3 is 6. That's where the hole is on this graph. So I know this graph has a hole at right 3 up 6. And literally a hole is a little open circle. Now, what does this graph look like? Well, it basically looks like it's reduced form. It looks like y equals x plus 3, which would be a line starting up 3 with a slope of up 1, right 1. So it's basically the graph of a line, except that we know that there's an open circle there in that. So I would just have a line with a slope of 1, but it's not quite a normal line because it has a hole at that single spot. So even though this technically is a rational function, it doesn't have like weird asymptote things like we're used to seeing. It just has a line with a missing spot in it. Letter B is going to be similar to letter A. I'm going to factor. This is 2x minus 3, x plus 2 for the numerator. Got an x plus 2 on the bottom. Okay, that means there's a hole at the number that makes both the numerator and denominator 0, which would be -2, comma. Again, I have to reduce that out. Oops, leaving me with 2x minus 3. Now, if I pop -2 into this, 2 times -2 minus 3, that's going to give me -7 for the y coordinate. So I know this has a hole at back 2, down 7, which again is just a little open circle. And then the graph of this will basically just be the graph of this line with that little hole in it. So starting down 3, my slope is 2, so up 2, right 1. Or I could go down to left 1, and you can see that if I kept going down to left 1, it would go to that open hole there. So really, again, it's the graph of a line almost. It's the graph of a line with a single missing point within that line.